The purpose of this lesson is to introduce you to the Python interactive prompt and to introduce you to Python's number types, of which there are 3. To get Python started, in a Mac, open a terminal window. In a Windows machine, open a CMD or PowerShell window. In either event, you will type the command Python to launch the Python interactive prompt. The triple chevron you see on the left tells you Python is ready to do work. So let's go ahead and cause it to do something. We're going to work in the beginning with Python's whole number type, the integer type. So if you type 3 plus 4 and you hit enter, Python will evaluate that expression and return or echo back the result of that evaluation. Addition, subtraction, work, unsurprisingly, multiplication. You can multiply. Now, division is a little different because there are 2 types of division. One type of division is you divide 2 integers and Python returns a floating point expansion of that quotient. 3/4 is 0.75. However, if you hit a double slash, Python performs integer division. And what it does is it takes the result of floating point division and truncates it towards 0. Simply chops off the decimal part. You'll notice that if you do the same thing minus 3/4, which is minus 0.75, and then you do integer division, minus 3, double slash 4, and it rounds it down. So let's try doing this with negative numbers and see what happens. If I go minus 3, double slash 4, and hit enter, the result is -1, because minus 3 divided by 4 is -0.75, and Python takes whatever you integer divided by and rounds it down. So it's actually, in mathematical parlance, flooring that floating point value. Okay, you might ask, what happens if I add a floating point number to an integer, 3 plus 4.0? Python automatically changes the integer to a floating point value of 3.0 and adds it to 4.0, and the result is a floating point number. So when you do arithmetic operations that combine integers and floating point numbers, the result will be a floating point number. Now, one thing that's interesting to note is that every Python object is acutely aware of its type. If I type type of 3, it says I am an integer. If I type type of 3.0, it says I am a floating point number. Now, one thing you're allowed to do in Python is to cast. Cast is a temporary request to regard a piece of data as of one type as being of another. Now, Python will do that if the conversion is reasonable. For example, if we go float of 3, we'll get 3.0, unsurprising. If we go int of 2.5, truncation occurs. If we go int of minus 2.5, Python truncates again the decimal part and rounds it down towards 0. So that's a little different from integer division. So we've now seen floating point numbers also have all the arithmetic operations. You can add them, you can multiply them, you can divide them. You can also do this. And Python recognizes scientific notation. So that's 6.05 times 10 to the 5th power. So we have integer arithmetic, floating point arithmetic, and we have one other type of arithmetic, complex numbers. To make a complex number, you say complex, and then what the real and imaginary parts are, and it comes back with a representation of that complex number as 3 plus 4, j. Now, j is the name that engineers give the imaginary unit. Mathematicians say I, but engineers say j. And there are, in fact, a full complement of arithmetic operations. Say I want to multiply a complex of 3, 4 by a complex of 2, 1, and that will happen. Here, let's take complex of I, that's I, 0 plus 1i, and square it, and you get, as you would expect, a -1, but the -1 has been promoted to a complex number. We're not going to spend much time on complex numbers in here, but if you were using them, you want to be aware of them. And you can say type of 3, 4, and the result is class complex. Okay, so what we've learned today so far is Python has numbers. There are 3 types. There are integers, floating point numbers, and complex numbers. Now, one other thing we should talk about here is order of operations. The order of operations for arithmetic operations is what you learned in Miss Wormwood's algebra class, PEMDAS. Parentheses first, then exponentiation, then multiplication and division from left to right, then addition and subtraction from left to right. To override the order of operations, use parentheses. Now, here is one thing you should be aware of. I'm going to multiply 5 times 2 plus 1 and get 15. However, if you do this, like you might do in a math class, you'll get an error because that parenthesis means something else. Now, if you're familiar with other computer languages, you'll know this callable thing refers to functions. So it's thinking that you're going to use 5 as a function, and you're going to apply it to 2 plus 1, which is kind of nonsensical. Now, the next thing you want to know, now that we know something about numbers, is how to get out of Python cleanly. And there are 2 ways. One way, you can type quit in empty parentheses, and you're out. Now I'm going to go back in. Another way to do it, if you are using a Mac or a Unix machine, hit Control D. If you're using Windows, hit Control Z, and you will cleanly exit your session. So this is an introduction to Python's number types. To summarize, there are integers, which are whole numbers. There are floating point numbers, which are IEEE 754 64-bit floating point numbers. You can look that up on Wikipedia, and it will give you the details on how those numbers are stored. And then there are complex numbers. One last thing to be aware of is, in many languages, integers have a maximum size. Now watch what happens when I do this in Python. If you try to do this in your calculator will register an error because it'll be too big. Oops, I need to go back into Python. For $1000, Python will compute with integers of more or less arbitrary size, subject to the limitations of your computer's memory. Floating point numbers do have a maximum size, which is roughly 10 to the 308. And complex numbers, when you start working with them, you'll see that the real and imaginary parts will be floating point. So they'll have a limitation too. However, this large integer type allows you to do interesting things with such applications as cryptography. So now you know about starting Python, leaving Python, that Python objects all know their type, and how to exit cleanly. And next time what we'll do is we will talk about variables and how we tie variables to objects, and maybe we'll talk about 1 or 2 other types in Python. But I think that